Good everyone, my name is Graphics. Today we want to study another aspect of engineering, which is heat transfer and energy conversion. We'll be analyzing what combustion is and we'll solve a problem under this topic. Now, if you look at the word combustion, it means burning. Like when something burns means that that particular thing loses some of its qualities, right? So when you say combustion, there are two types of combustion. We have the complete combustion and we have the incomplete combustion. Now, for something to combust, to burn, there must be some certain amount of oxygen and nitrogen that will be present in that source element for it to what? For it to burn. Right? Now, when you say the combustion is complete, it is when all the carbon that is present in the fuel, right? Your fuel can be methane and so on and so forth. Where all the carbon present in the fuel, we call them hydrocarbons. So in hydrocarbons, there are a lot of carbons that are present in them, right? If you are familiar with your chemistry, you get to understand what I'm trying to say here. So for a combustion to be complete, we say that all the carbon present in the fuel is burned down to carbon dioxide, right? And all the hydrogen present in it is burned down to water, and all the sulfur present in it is burned down to sulfur dioxide. And other combustibles, because air is a mixture of what? Of gases. So all other combustibles also must be burned down fully to their oxide. And when they are burned down fully to their oxide, in that state they are not harmful to our health. Is that okay now? Now, when it is incomplete, it means all these elements are not completely burned down. So instead of carbon dioxide, you'll be saying carbon monoxide, which is poisonous to the health. So let's see how we can analyze this question. It says methane, which the formula is CH4, is burned with dry air. We all know air is a mixture of gases. The molar analysis of the product on dry basis is carbon dioxide is 90.7%. That is the amount of carbon dioxide present. Carbon monoxide is 0.5%. Oxygen is 2.95%. And nitrogen is 86.85%. We are now told to what? Determine the F-well ratio on both molar and mass basis, and also the percentage theoretical air. So what you do, the first thing you do here is this: solution. We said earlier in our definition that for complete combustion to take place, if you have a fuel, right, for that fuel to burn, we have two things that must be present for it to burn. One of them is nitrogen and the other one is oxygen. So what you do is this: you write down, you see that for complete combustion of CH4, so I said for complete combustion of CH4 with theoretical amount of air, that means when any fuel wants to burn, it must surely react with some amount of air, and this air must have majority of what? Nitrogen and oxygen in their right proportion, right? So it says for complete combustion of CH4 with theoretical amount of air, the product contains, let's see, what I'm going to do here is, my fuel is CH4, right? We have what is called the product. So the product here is the fuel and the amount of air, which I mean that contain nitrogen and what? Oxygen. So plus I have O2 plus 3.76 N2. So the amount of oxygen I was producing was what? 3.76. Then this is what we have. Are we good? So this is reactant. This is what is reacting. So these two things is going to give us some product. And in every reaction, there must be a product. So the reactant is going to give me a product. Now our product we are given here, we are told that we have carbon 4 oxide or carbon dioxide 9.7%. So we have 9.7% of what? CO2, right? Plus we have 0.5 of CO. 0.5 of what? CO. We have 2.95 of O2 plus 2.95 of O2, that's oxygen, then 86.85 of N2. We have plus 86.85 of N2, right? And we have this, and there must be water present because the hydrogen here, this hydrogen present, will be completely burned down to what? Water. I'm going to put plus H2O, which is the water. Now, this is what we have. Is that okay? But we know the amount of carbon dioxide, carbon monoxide, oxygen, and nitrogen. But we don't really know the amount of water present. We don't know the amount of fuel that is being burnt and the amount of the air and nitrogen present. So what you do is you put a variable, something to represent them. This will be A, here will be B, right? And the oxygen here will be what? C. Is that okay? So you now apply the conservation of mass to carbon, hydrogen, and oxygen. So you write it there that applying the conservation of mass to carbon, then hydrogen, right, and oxygen, So we're going to apply the condition of mass on these three of them. So like I said earlier, we have two parts of this equation: the product, the reactant, which is what gives us this, and the product. So if you look at this, for carbon, right, for carbon, such that, now you look at the left hand side. The left hand side is from this arrow backward. So you look what is in front of them. Now in the left hand side, we have just the amount of carbon there is just A, right? So we only have A in front of carbon, so I'll put A in the left hand side. Now there's no any other carbon at the left hand side, right? Now you now put your equal sign to show that this is the left hand side. Then at the right hand side we have carbon here, and that is 9.7% of carbon. So it will be 9.7%, right? I also have another carbon here, C, and that is what? Plus what? 0.5. is that again? You see what I did? At the left hand side is A, only A carbon that is present. At the right hand side, 9.7% of C present, plus 0.5 of C present. There's no any other C here. So when you add both of them, we say that my A is equals to what? 10.2. That is my A. How good? Now, in terms of H, which is hydrogen, such that, now if you look at that, at the left hand side, from here backward, hydrogen is 4, here, right? But there's A here. So the A in front of this is affecting everything. So if there's A in, I can write the A here, I can write the A here. So A is affecting everything. So since I'm having 4 hydrogen, it will be 4 times A. And that will give us what? 4A at the left hand side. Is there any other hydrogen here again? No. So you put your equal sign to show that you're going to the right hand side. Now if you look at this, there's no hydrogen here, no hydrogen here, but there is one hydrogen here. And that is in terms of this. Can you see that? There's one hydrogen here. You can see CH2. So you multiply this 2 times C will give us 2C. So we have 2C there. Is that okay? Now what you do now is we've already gotten A in this here. So you substitute A into this A here. So we now have, I'll write that since A is equals to 10.2, therefore we have 4 bracket 10.2 is equals to what? 2C. So when you multiply 4 times 10.2, you have 40.8. So I'm having the 40.8 all over what? Divide both sides by 2, this will be 2. I will have C here. So automatically the C is giving us what? 20.4. When you divide it, so that is a C present. Are you with me? So if you multiply this times this, you have 40.2. So you divide both sides by 2, this will be this. So that is C there. Then the next one is for oxygen O. Let me just do it here. Oxygen O. Such that, right? So let's see. Or better still, let's just come and do it down here. For oxygen O, look at the left hand side. At this point here, if I expand this, B times O to give you BO2, so 2 times B will give you what? 2B, right? So we have 2B. So you put your 2B. I'm talking about my left hand side now. So we have 2B. Now is there any other oxygen here again? No. So equals to, we're going to my right hand side after the arrow. So if you look at oxygen, this 9.7 is affecting everything, and oxygen has just 2 here. So 2 times 9.7, so we put it 2 into bracket 9.7 plus another oxygen again here. This 0.5 is affecting everything, both carbon and oxygen. So O in front of this, like 1 you have there. So 1 times 0.5 is 0.5. So I'll have my 0.5, right? Plus, we have another oxygen again, which is 2.95. So 2 times 2.95. 2 plus 2 times 2.95. Right? Then plus the next oxygen again we have here is in terms of water, which is CH2O. So 2, this oxygen here is 1. So 1 times C, because C is affecting everything. 1 times C is C. So plus C. Right? So we'll see so plus C. So the next one will be in terms of what? Oxygen, O2. So in terms of oxygen, O2, let's see, for O2, for O, such that we look in our left hand side, we see that we really have this O2 here, but it's inside the bracket. So we need to open the bracket for to access the O2. So B times O2 give you BO2, right? So if you multiply 2 times the B, it will give you 2B. So we have 2B in my left hand side because there's no other oxygen, right? Now the next one in my right hand side, I'm going to put equal sign so that I can access it. Now we have oxygen here, O2, right? And we have 9.7. 9.7 here will affect everything. So 2 times 9.7 will give me, I have 2 times 9.7, right? So the next one is 0.5 CO, right? So we have O here, 1 times 0.5, 0.5 plus 0.5. And the right hand side we also have O2 here and 2.95. So 2 times 2.95 will give us plus 2 into bracket, or 2 times 2.95, right? Then we still have one oxygen here. We have H2O, right? And the O is here and the C is here. So in front of the oxygen is just nothing, so the C is affecting it. So C will just have plus C. Plus C. Now in doing that, we'll see that 2.97 is going to give us 19.4. So 2B is going to give us 19.4 plus 0.5 plus 2 times 2.95 will give us 5.9 plus the C is 20.4, just like what we have here. Our C is giving us what? 20.4. You can see that. So we move forward, and when we add everything, we say that 2B here is equals to, you add all this together. When you add them, you'll be having, we have 46.2. So if you divide both sides by 2, my B will give me this 6.2 over 2. So when you divide 46.2 over 2, so we have 23.1. That's the amount of B we have. So we'll now rewrite it, right? You've already gotten all the values from here, A, B, and what? And C. So we put them, we write them, and we put the value. So we'll now write that the balanced chemical equation is, so let's see, let's move forward. So we're going to write that the balanced chemical equation is, let's see, now I have from here, I have ACH4. And now what is A? A is giving us what? 10.2. So I write 10.2 CH4. So I'm having from here 10.2 CH4. Now the next one here we have is plus B. So we have plus B. What is B? 23.1. So I'll put 23.1 open bracket. I have O2 plus 3.76 and 2. So I'm replicating this guy I have here. B is 23.1. Then I hide all this back. Right? That is the product, the reactant. So the reactant is going to give us the product. So our product here is going to be, let's see, 9.7 CO2. You write it out. 9.7 CO2 plus 0.5 CO, 0.5 CO plus 2.9502, we have 2.9502 plus we have 86.85 N2, 86.85 N2 plus CH2O, but our C value is given to be, the C value here is given to be 20.4, right? That is 20.4, that is the C value here. You can see that? 20.4. So I'm going to put the C value there, which is 20.4. So plus 20.4 H2O, right? So this is the balanced chemical equation. Now the question here says something. It says from here, it says the F-wear ratio on both molar and mass basis. So we want to know the F-wear ratio of both molar and mass basis. The question says we should look for what? We should look for the F-wear ratio on both molar and mass basis. So you're going to write for molar basis, right? So on a molar basis, right, our F-wear ratio, you put it AF and you put a bar on it to show F-wear ratio on a molar basis, will give us the molar mass of air all over the molar mass of the fuel, right? So what is molar mass? When you talk about molar mass, it says that the molar basis, this is the proportion of the reactant needed to produce the product. So the proportion of the reactant needed to produce what? The product, right? Based on the molar ratio of the reactant. So if you look at this now, in terms of air, what is the portion of reactant needed, right? If you look at this now, we have 3.76 of nitrogen, that is 3.76 moles of nitrogen plus 1 mole of oxygen times 3.1 is needed. So what I'm going to do is I'm going to write 23.1 into bracket 1 mole of oxygen plus 3.76 mole of what? Nitrogen, right? All over, in this we only have 10.2, so we'll be having all over 10.2 moles of the fuel needed. So if you do this from this aspect here, we are going to be having this to be 23.1 into bracket 4.76 all over 10.2. So my value here for my F molar mass basis of F-wear ratio will now be 10.78. We have 10.78 IB mole of air all over the IB mole of fuel. So that's what we have there, 10.78. Now on a mass basis, now the F-wear ratio on the mass basis, we'll move forward. F-wear ratio on a mass basis, on a mass basis, we're looking for F-wear ratio, right? So on a mass basis, you're going to put F-wear ratio, but you will not put bar on it to show that it's on a mass basis, and that will give us the F fuel ratio on a molar basis, which is 10.78, all multiplied by the amount of air present on a mass basis, which is the constant of 28.97 if calculated, all over the amount of fuel present in it on a mass basis. So how are you going to do that? Let me just tip you in. You know the fuel present here is CH4, and then the fuel we have here is CH4. So when you say CH4, the atomic mass of carbon is 12, and the atomic mass of nitrogen is 1, right? So 4 times 1 is 4, right? So add it with 4. This times 1 is what? 4. Then atomic mass of C is 12. So 12 plus 4 is what? Is 16. So divide this all over what? All over 16. So at the end of the day, if you do your estimation very well, our value here will now give us 19.47. That is the on the mass basis present. So you're going to put your formula IB mole all over what? Mole of air all over IB mole of fuel. So we have 19.47, right? Now in the B part given here is this. Let's see. The B part is saying we should calculate the percentage theoretical air, right? First of all, we have to balance it. The balanced chemical equation for complete combustion of methane with theoretical amount of air will be the CH4 will react with some amount of oxygen and 3.76 of what? Nitrogen, mole of nitrogen, right? So when you react, it's going to give us three things, which is carbon dioxide, water, and what? Nitrogen. And the three things will give us. So we have to balance it. Now if you look at this here, we have oxygen here as what? We have if I put 2 here, it means the hydrogen here will be nitrogen here will be 4. Hydrogen here will be 4, right? And we have 4 hydrogen here. So the hydrogen amount of hydrogen is what? Is balanced. Then in terms of oxygen, I have 2 here, right? So when I put 2 here, it means we have 4. Oxygen will become 4, because 2 times 2 is 4, right? And we have 2 here, oxygen here, and we also have 2 oxygen here. Now, but the nitrogen will be 2 times 3.76 will be what? 7.52. I'll put 7.52 here. So this is the balanced chemical equation here. So what I'm going to do now, I'm now going to calculate the air fuel ratio molar mass basis again for this. So I'll say that the theoretical air fuel ratio on a molar basis is, now from here you put your AF and you put dot on it, so it's on a molar basis, and if you look at it very well, it equals to the air fuel of the air over what? That of the fuel, right? So if you look at for the air here, we have 1 mole of oxygen plus 3.76 mole of nitrogen. That will give us what? 4.76. Then times 2 all over just 1 mole of the fuel, so over 1, and that is going to give us 9.52 IB mole of air over IB mole of fuel. Now you now write that the percentage of percentage theoretical, this is what you will have to calculate for the percentage theoretical of air. It will be the molar air fuel ratio on a molar basis all over air fuel ratio on a molar basis in the term of what? Theoretical. And what calculated is that for the first one we have 10.78, and for this one now we have 9.52. And when you divide them, and that will give us 1.13, and in terms of percentage it will be 113%. So that's what we have here. So the 10.78 is gotten from this man here. Let's see, gotten from this here, 10.78 here, right? Normal way. Then for this over this guy here, 9.52. So we'll have that. So that is that's how we calculate percentage theoretical air. So if you found the video helpful, don't forget to click on the subscribe button. Thanks for watching.